In this Godot tutorial, I'll teach you what you need to know about the animation tree and how you can use it together with the animation player to substitute many lines of code in your script and make your life a little bit easier once you get the hang of it. Let's dive straight in. I'm here on my player scene where I'll be adding the animation tree. I'll add it as a child to the main node, already search for animation, and I'll add the animation tree. Do not add the animation tree player, that is another node for another tutorial. With the animation tree added to the scene tree, we open up with a couple of errors. This is normal because we have to set some parameters. Now before we do, let me go over the difference between the animation player and the animation tree, as it seems to be the cause for some confusion. The animation tree is not a substitute for the animation player. They work in conjunction, and actually the tree cannot function without the animation player. So don't go off and deleting your animation player. You'll regret that later. So what is the difference? You can look at the animation player as the place where you define and store your animations, just like we got here. In the animation tree is going to be determining based on with the animation stored in the player, the tree will determine what animation should be shown at what time. So the animation tree is more like something that replaces the code that you would normally use if you were to only use an animation player. So with that difference out of the way, let me also say that this entire project, without the tree here of course, is the previous tutorial where we have gone over the animation player and how to add all these animations. If you haven't seen that tutorial yet, or if you don't have something similar like this for a player or an enemy, then please watch the tutorial first and then come back here, else you would have a hard time getting this working. So with that said, let's fix this animation tree up and make sure that it's ready to go for our project. The three settings that we have to set to make these errors go away are the top three parameters in the inspector right here: the tree root, animation player, and active. We can't turn this on active on yet, as it won't turn on until the tree root is defined. Now for the tree root we got a couple of options, and it already shows the versatility of this node. This node is quite powerful, but this might be a little bit too much information to go all over if you're new to the animation tree, which is likely because you're watching a tutorial about it. So I'll give you a quick guideline. The node animation, blend space 1D, blend space 2D, and the root node are generally not used as tree roots. We are going to be using the blend space 2D in this tutorial, just not as a tree root, but as a node within the animation tree. So what is the general guideline? Use a animation node blend tree for 3D games and animation node state machine for 2D games in this field here, in this parameter for the tree root. We're working in 2D art right here, so we're going to go for the node state machine like I said. The animation player is basically assigning the animation player to this animation tree. Like I said, this tree cannot work without an animation player. You need to have one. So when you click that assign button, this little pop-up opens up basically with the same node structure as the scene tree right there. We select the animation player and we hit OK, thereby we assign the animation player to this tree. Now with those two properties set, those two parameters, we can activate the tree, and now the errors down here are gone and we're ready to go. Okay, so now we have our animation tree ready to go. There's a couple of buttons and a transition and play mode menu on the top here. I'll explain what that does a little bit later on once we got an animation in here, because it's easier to explain with an actual example. To start it off, or to start adding an animation, you right click in this big empty panel. That opens up a couple of options. Options that probably look familiar as they're almost the same as what we had under the tree root. Now you might be tempted to immediately go for add animation. The thing is that we want the animation tree to manage the direction of the animation. And for that we're going to make use of a blend space 2D. Now this is going to be a little bit complicated, so bear with me, rewind, pause, playback whenever you need. We add the blend space 2D. That doesn't really do a lot. We can click it and we can rename it. That's handy because else you get lost. This basically has three options: the renaming part, the play part, and this little pen here which lets you edit it. When you click the pen, a new tab opens up. So now we got the root here, and we have the idle animation, the idle blend space 2D right there. Now to make this a little bit more, give us a little bit more overview, I'm gonna be hitting this icon right here. That is gonna open up the panel, make it bigger. So what this is basically a 20 by 20 grid. So it goes from -1 to +1 and -1 to +1 on the X and the Y axis. Now what we're going to be doing is usually what you have, and I call it this, but it might be called different. I call it coordinational input. Basically, when you use, for example, the keys on your keyboard, WSAD, or the arrow keys, what you usually end up with in your movement loop is that whenever a button is pressed, X, for example, is +1 or Y is +1. Well, that directional input, then you multiply with speed and you multiply it with delta to make sure that the player always has the same speed. But that original X and Y value based on those arrow keys, which can always be a maximum of +1 and a minimum of -1, that is the coordinational input that we can use and transfer here to the blend space so that the animation tree manager can pick the right direction of the animation. That's what we're gonna do, and I'll show you how to do that. So there's a couple of things here that you need to know about. First, we have the blend space, or set the blending position. That's basically this little crosshair right here that we can drag around, easy to have for testing purposes. Then we have the arrow point to select any animation that you may have already added. And we have the create point. There we can create points and we can add animations to this blend space 2D. Now we can set the snapping of the X and the Y axis. So now it's a 20 by 20 box, but if you need it to be different for some reason, you can change that here. And you got the blend mode. The blend mode is basically gonna, for 3D, the blend mode is very important, so it can interpolate between two various elements, or also in a 2D game when you're blending positions or blending scaling or something like that, you can get like halfway in between 2 points, and then the animation tree can blend it for you, get to the right point in between to interpolate in between. However, we are working with textures here from a sprite sheet, and there's no real way that a computer can interpolate between textures. Well, actually, they can in Photoshop, but it's very heavy calculations that you would never do in a game at runtime. So we're going to change the blend mode to not interpolate and to just take them as points in the space. So now, still with our add points selected, we can actually add these points with the left mouse button. So when I left click right here, I'm going to add an animation, and I'm going to be adding my idle west, as this is the left side of the screen. I'll do exactly the same on the other side here. Now add my idle east. Now you'll be tempted to now go to the top and say, okay, so this is going to be idle north. And that's where you're wrong, because compared to how the coordinational system works in Godot or most game engines, this is actually inverted. As you know, when you move down in a 2D space, when you move down in Godot, the Y increases. But here the Y increases when you go up. As you can see, this is the positive Y and this is the negative Y. So you have to change that around. It's very counterintuitive, and as far as I know, there's no way to change that. If anybody knows how to change that, please let me know in the comments. So we're going to go down to the top here. We're going to go to the top, and we'll be adding the idle south, because south is positive in Godot and this is positive in the blend space. And we'll add idle north down on the bottom here. As I said, we got a directional sprite sheet. We'll only be adding 4 right now. I'm not sure if I said it already. Anyway, we're going to start off with 4 directions, because adding the isometric 8 directional part is like another level of complexity, and let's do one complex thing at a time. I think that will be a good idea for us. So now what we can do is we can make this smaller, and we can go back to the root, and we can hit play, because now we actually have some animations. And as you can see, the skeleton is standing still. When I press play, we got a moving skeleton. He's currently facing north. Now going back to that animation, I can now should not make that big. I can now pick up the blend space. And now, as you can see, when I move close to any of the coordinates, the animation shifts its rotation, or another way, another animation is picked based on the blend space coordinational input. Now, as you can see, it's not switching hard, it's going to whatever it's closest to. And of course, closest is better represented in this right here. Even in this mode, the squares are not perfectly square. Rectangles are not perfectly square. But yeah, this is how it works. So the closest coordinate or the closest point is picked as the animation that should be playing. So even if you got like joystick input instead of hard values with the arrows, or if you got, I don't know, mouse input, then your character can rotate in every degrees in radials. That doesn't matter because it always picks the closest one, the closest animation. So that's good, that's great for us. So now that we have added this animation, we should have a look at adding the walk animation, because we require the walk for our code to start handling that. So we'll add the walk animation, or I'll do that off screen probably, as it's exactly the same. And then we're going to connect them up together. Then we're going to change the code. And then lastly, we'll add the other 4 directions of this 8-directional isometric sprite sheet. So hang in there. So now I have 3 blend spaces, one for idle, one for walk, one for melee. I set up the walk and melee blend spaces exactly the same as I did the idle. So we can go over them really quickly. I've hit play for walk. When you look at this one, basically it's 4-directional with the input, just like the idle system. For melee, exactly the same, but then of course with a melee attack. Now, important for the melee attack, for the animation tree to work properly, we need to make sure that the animation is looped. That is the opposite of what we do when we only work with the animation player and code. So make sure that for all your melee attacks inside the animation player, you turn on that loop right there, even though you would not do that when you don't use the animation tree. Now, okay, with that said, let's hit the idle animation, as that's a little bit calmer. The next thing we have to do is we have to tell the animation tree the paths with which it can travel from one blend space to the other. I know the word travel may sound a little bit weird at first, but it's actually a common used term in animations and switching between animations in game development. So basically what we have to ask ourselves is what animation transitions should be possible, and we have to build those paths. So whenever we're standing still and we start moving, either by a point and click input or by the keys on our keyboard, we want to be able to transition from idle to walk. And as you can see with this connect nodes tool selected, I can drag from one node to the other, from one blend space to the other. So of course, when we're idling, we should be able to switch to walk, and when we're walking and we've reached the point of the that we clicked, or we stop hitting the movement keys on our keyboard, we need to transition back to idle. Now these transitions, whenever you select one of them, you can select them using the selection tool right there. You also have a delete tool. You have a transition, and a transition can be immediate. You can set a transition here, or you can set the switch mode right there. So it can be at end, or you can set the at end right there. We also have an option auto advance, but none of these are really necessary for the transition between idle and walk, because as soon as you hit a button for walking, you want to start the animation for walking, and exactly the same the other way around. As soon as you stand still, you don't want to be moonwalking in the place, you immediately want to transition to idle. Now for the melee attack, it's going to be a little bit different, and that is where I can show you how these various options work. So for the melee attack, the first thing we did in the code when we programmed this in the first place is that whenever we are attacking, we're standing still. In other words, we always attack from an idle position. Even when we're walking, what would happen in a single frame that is indetectable for the player is we transition to idle, and then we transition to the melee animation. So we're not going to make any connections between walk and melee. Instead, the animation tree, whenever it detects the melee input or attack input, will transition from the walk animation, traveling via the idle animation to the melee animation. So that's where the traveling comes from. So for the melee, we're gonna idle straight into melee. There's going to be an immediate transition. We don't want that to be any delay. But when we go back from the melee to the idle position, of course, we want that only to be able to be possible whenever the melee has finished. The attack has finished. The animation needs to finish. The entire melee attack needs to finish else you would be able to quickly lash out and then walk away again, and that's not what we want. That's also not how we've coded it. So with this transition selected, we're going to go over to the switch mode and we're going to set this to at end. That way it will only transition when it's at the end of the animation, and it will recognize the end of the animation even if it's looped. Now we don't only want that, because we can also tell the animation tree node, we can tell it to automatically advance at the end. So what happens now is that whenever we're walking or idling, whenever we're attack, melee attack will play and it will automatically advance at the end of the animation back into the idle animation. So that whole going back to the idle animation, that is all handled by the animation tree now, and we can remove all those lines of code from our script, seriously cleaning up our script and thereby making our script so much more give us so much more overview basically in our script. So now that we have defined all the travel paths, final thing we can do is, with the idle animation selected by clicking in the box, we can also set the start animation. So gotta select again. Here we have a toggle autoplay this animation on start. So whenever we load the game, we start the animations off in the idle blend space, so with the idle animations loaded in. That's like the last thing we can do here. Now we can switch to the code and we can replace all those lines of code from the last tutorial that we needed for just the animation player, and we can add the lines of code that are necessary for this animation tree, which is only a fraction of what we have right now. So let's go over to the script. So now for the code, let's switch over to our player script. And let's start off with coding by ripping out all the lines of code that we no longer need. This is of course the script from our previous tutorial where we only had the animation player and we were setting the animations through the code. Now that we're setting the animations through the animation tree, a lot of code can be removed. This helps us to give us an overview, and it will also show you how much lines of code the animation tree can substitute for, and therefore how powerful it is. So first of all, we have in the process function the animation loop, which is playing all the animation. We no longer need that, so I'm going to replace this animation loop call with a pass, as the process function can of course not be empty. I could also delete the process function, but pretty much every game needs a process function on the player script, so we'll probably be making use of that later. Now with that animation loop gone, we can remove this rather hideous line of code with all these if statements, as we no longer need this. And also the variables animation, animation direction, and animation mode that are being used in this animation loop and defined on the top here can be removed, as we no longer need them. Now with that animation mode gone, we now pop up an error here on the attack function, as we're setting the animation mode to idle after we have set our 4 seconds yield for the 0.4 seconds that the attack animation lasts. But as we have set with the travel paths that the attack or the melee animation automatically advances after it's done, we already pretty much set that up in the animation tree space, so we can remove this animation mode to idle as well. Now the animation loop was also making use of the move direction to make sure that the right animation in the right direction was picked. Now that the blend space 2Ds are going to help us with that, we no longer need a move direction, and the same is true for the attack direction, no longer need those. And as the move direction and attack direction were only used at those moments, we can also delete the variables move direction and attack direction. Now with that all done, I think that's it. Yeah, that's our code stripped. So from about 150 lines, we're now down to 50 lines. That's a pretty good improvement. Now on the top here, of course, we do have to add a couple of lines for our animation tree. So we start off by saving the reference to the animation tree node in a variable animation tree, as we'll be making use of that several times over. And we set the animation mode as the animation tree get parameters playback. Now, what's that? I'll explain it to you, kind of important, and this is where you'll start to see where the magic is going to happen. With the animation tree selected back in the inspector here, we have the parameters. And under the parameters, I'll close these up, we have our playback. And if I hover over that, this is where you see property parameters / playback. So that is the parameters playback we have right there. Make sure you hit the correct capitalization there, else you're gonna run into errors with this. Now the playback has access to idle, melee and walk. Those are our free blend spaces. So you can see the idle, melee and walk here as sort of the modes of the animation tree, or the modes that it has access to. Hence why I call this the animation mode as the variable name. Now the idle, melee and walk all have blend positions. Those blend positions, if I go back to one of these blend spaces, is of course the blend position that we set with the crosshair here. In other words, we can set the crosshair through, oh, this is the wrong one actually, so that's funny. Oh, there we go. No, it was the right one. It switched a little bit later because there's a little bit of a delay in there. That doesn't happen at runtime, don't worry. But these blend positions with their respective properties, parameters, idle, blend position, is what we're going to set through code. Thereby we're going to virtually set that crosshair, and thereby we set the right animation direction for that particular mode. So of course we need to set all of these to 0, or actually it's not absolutely necessary, but I just like to have that because I don't know, I guess I got OCD or something like that. So I'm just going to set them all to 0, 0, 0. Now with this animation mode available to us, with the animation tree available to us, and with our code stripped, we can now start adding lines, making sure that all of this becomes functional. So now we have to add the correct blend positions and activate the right modes. Under the unhandled input event right here, I've added under the isActionPressed attack, so that will be the right mouse button for attack, I've added this print command to show you how we can do this. Right here we're printing the current position of the player, the direction to the global mouse position, normalize. And especially this normalize is very important, as this will take any vector2 and reduce it to a vector2 coordinational input amount -1 to 1 on both x and y output. That sounds a little bit complex. I probably made that more complex than necessary. Anyway, what you need to know is that the result of this will be a vector2 between -1 and 1 on both x and y axis. And that's of course perfect for a blend space, which takes exactly those coordinates. So if we would really quickly play this game, we have our character here. It cannot move, any animations of course are now ripped out. But if I right click right here, you see in the output right here that when I click south of the character, or as a perfect press actually right there, we get 0 on the x-axis, that's correct because it's right underneath, and 1 on the y-axis, which is of course correct because it's south. And it doesn't matter how far south I press, the normalize commands will always make sure that this stays between -1 and 1. Of course, when I click right, we're going to get 1 on the x-axis and 0 on the y, or -1 on the x-axis and 0 on the y for left or west. And of course, for top, it's going to be 0 on the x and -1 on the y. So this coordinational input is what we'll be transferring over to our blend position. So back into the code, I'll be replacing this print command right here. Or you know what, we'll leave it because we can use it later. I'll be adding these 2 lines of code. Now these 2 lines of code are going to take the animation tree, is going to set the parameters melee blend position. So that is under the tree, the blend position of the melee attack. And then it's going to be taking the position, direction to global mouse position normalize, exactly the same as what we printed just now. So this will set the crosshair in the correct location. But as you can see, we're doing this for both the melee and the idle animation. The reason why we do that is because imagine the player is standing still in his idle mode and it has its nose, sorry for that, it has its nose is looking into the direction south. And we click, right click, north of us to attack because, I don't know, there's an enemy there. So the player turns around, attacks, and what happens after the attack? It would if you do not set this idle blend position right here, it would switch right back because the idle blend position was still in the south direction. And then your character would constantly be flicking around whenever you attacked in a direction that was different than your current idle direction. So that would look really weird, and I've never played any game where that animation transition would work like that. So we need to set both the idle and the melee blend position so that the idle position basically copies over whichever direction we attacked in. Now, with that set, we also of course need to set the parameters mode blend position when we're walking. So in our movement loop, I've also added 2 lines of code right here. In this loop, it's basically going to go over how much pixels it can walk every single physics frame, and if it cannot, or if it is within 10 pixels of its target location, because this is a point and click game. So if it's within 10 pixels or not within 10 pixels, it will move. And for the movement, we have a vector 2 that is going into the move and slide, but we can also take that same movement vector, normalize it, and then set both the walk and the idle animation. And here again, we set 2 animations for exactly the same reason. Whenever we're walking and we're getting to the point of destination, we want the direction in which the character was walking and where it finishes walking also be the idle animation, the idle direction in which the character continues to watch. Otherwise, again, you're going to have flicking characters which look really weird. Now, of course, we are setting all these walk, idles, and attack, melee animation directions or blend positions, because that's equal to a direction right now. Now we got to make sure we activate the right mode. Now, for that, we of course have our animation mode right here, and we're going to go for animation mode. We're going to travel. Here is that word again, traveling from one animation to the other animation, as we were talking about at the beginning of this tutorial. And whenever we're walking, we're going to set the animation to travel to walk. And when we're done walking, when we're less than 10 pixels away from the destination, moving is false, then we travel to the idle animation. And whenever we are attacking, we of course take the melee animation. Now, with that done, and also I should say that because I tested this and things weren't working the way I was expecting them to work, apparently I had shifted from movement to idle. I had apparently shifted it. Let me quickly do that. I had it like this. So in case you were wondering why maybe something is not working for you, I had to put an extra tab in there. I'm not sure if I accidentally removed that from the last tutorial, or maybe even the last tutorial I forgot that tab. Not sure, but make sure that the right indentation is copied over from what you see right here in the video. Now, with all of these animations set, we should be able to play this game and see the correct animation. So when we left click from one location to the other location, and when we attack, you can see that we're transitioning from the right animation mode and in the right animation direction whenever we have went or walked somewhere and whenever we attacked somewhere. Now, of course, right now we only have 4 directions in, and this is an 8-directional sprite sheet. So let's add the other 4 directions real quick, and then we're done with this tutorial. So for the last 4 directions, this is actually pretty easy, and the reason why I've kept this print command right here. When I'm going again back into our game here, and I'm watching again the output, when we work with isometric art, like I do right here, I like to pick isometric art in my tutorials because they're the most difficult for 2D games. So if you're working with forward angled or top down, it could be a little bit different. Isometric art is drawn with a sort of 30-degree perspective. That means that the y-axis is sort of shrunk by 50% or compressed by 50%. That means that the animation directions are drawn in 30% as well. So you need to get about 30% here if you were to imagine 45, 30. And you'll see, well, this is the right one. There, I had a perfect one right there, because when you do the calculus with Pythagoras and tangens and cosinus and sinus and all that crap that nobody understands, or at least I don't, you get the perfect animation direction at 0.8 and 0.6. That is the normalized vector that is closest to the actual line of the animation, and where of course you want to have your animation being picked as that one. So we have to implement 0.8 and 0.6 as our coordinational input for the blend spaces in our blend space 2Ds. Now that sounds very complicated, but it absolutely isn't. We simply go back to the animation tree, we select the animation tree panel, and under the root, now we can do it for idle, that's fine. We're gonna change this, we'll make this a little bit bigger so the counting is easier. We'll select that add point tool, and now we're just gonna go, well, 8 on the x-axis and 6, 4, 6 on the y. Here we're gonna add our animation south, don't forget that, y is inverted in the blend space, so it's gonna be southwest. We'll do exactly the same right here. We got 8, 2, 4, 6, add animation southeast. And here we have, yep, right here, idle northeast, and then wherever those points intersect, idle northwest. Now that gives us this sort of, I don't know, weird spider web. We have the right animations in the right locations. Now you would have to do this for both the melee and the walk animation as well, of course, but other than that, we don't have to do anything. All we can do now is play, and we will see that when we hit a directional, the movement of the walking animation, of course, does not have this, but you'll see that the idle animation at the end of the movement is now in that direction. And we can do exactly the same here, or for an attack, you'll see that the idle animation is correctly picked, as the idle animation blend space has access to more varieties of animation modes and animation direction, and can pick the closest one right here. So if you were to add this to also the melee and the walk animation, or not animation, blend space actually, then everything would look perfect, but I trust that you will be able to do that by yourself and don't need me to make this tutorial any longer than it already is. That was it for today, guys. Hope you like it. If you did, smash that like button, hit subscribe. Don't forget that little bell icon to make sure that you don't miss out on the next tutorial. There's also a couple of links in the video description. One is for the Discord servers, where you can hang out with hundreds of Godot game developers. There's one for my Twitch stream, on which I live stream my own game development on a commercial title. That's every Tuesday and Thursday. Link, schedule and description are down in that description box. I hope to see you on my stream one day, and then otherwise one day on another tutorial here on this YouTube channel. Until then, keep on gaming, keep on coding. See you later, guys.